Now I'm going to talk about solving linear inequalities. Solving linear inequalities is extremely similar to solving equations. In fact, they have the exact same steps, except for we need to change or tweak the last step just a little bit. So I've got the steps listed out here. Notice they are 1 through 4 are the same as they are for solving equations. I first distribute, I combine like terms on each side of the equal sign. I make sure that the variable is only on one side of the equal sign. I get rid of anything that's not attached to the variable using addition or subtraction. And then I get rid of anything that is attached to the variable by using multiplication or division. This is the extra piece. With equations, my equal sign doesn't look any different if I turn it around. However, with inequalities, if I turn it around, it changes from greater than to less than, from less than or equal to the greater than or equal to. I need to make sure that if at any time I multiply or divide both sides of an inequality by a negative number, that I turn that inequality around. So let's go ahead, and I have 3 examples here. Let's look through these 3 examples and see how this works. At any point, because they're very similar steps to what you used with solving equations, at any point that you want to pause and try on your own, please feel free to do that with any of these problems. On the first example, first thing I'm going to do is use the distributive property to get rid of those parentheses, giving me 2x minus 8 plus 6 is less than negative 8. From here, I have 2 sides, and on my left, I notice I can combine a negative 8 and a positive 6. My signs are different. I subtract, I keep the sign of the bigger number, and it becomes negative 2. Now I can get rid of anything that's not attached to variable. I can get rid of the subtract 2 by adding 2 to both sides, leaving me with 2x is less than negative 6. Finally, I divide by a positive 2. Since I'm dividing by a positive, I'm not going to change my sign, and I get x is less than negative 3. And I see that my directions told me to both solve and graph, so I'm going to go ahead and graph my solution. So just like we saw, I'm going to go ahead and find negative 3 and label that on my graph. I'm going to use an open circle at negative 3, and I read that its x is less than negative 3, so I'll shade everything to the left. So I have my solution as well as the graph to my solution. Looking at example 2, I see that I don't have anything to distribute, so I'll skip step 1. But I do see that on the left side of my inequality, I have a 3x minus 6x. I combine them, giving me negative 3x. Subtract 5 drops down, greater than or equal to 13. Now I see that I do have the variable on one side. I can get rid of that add or subtract. So I add 5 to get rid of the subtract 5. And I get negative 3x is greater than or equal to 18. And now to get rid of that negative 3 that's attached to the x, I'm going to go ahead and divide. And notice this time I'm dividing by a negative. So my negative 3's cancel, and I go ahead and say x. I turn my inequality sign around, so it's going to change from being greater than or equal to being less than or equal to. 18 divided by negative 3 gives me negative 6. And just like before, I now need to graph that. So I set up my graph. This time I'm going to put a closed circle at negative 6. I go back and I reread, and I read that x is less than or equal to negative 6, so again I shade to the left. Looking at one final example. So I notice on this example, first thing I'm going to have to do is I'm going to have to distribute this minus here. And I'm also going to have to distribute this 2 in. So my 4 drops down, and I get 4 minus 2x minus 3 minus 4x is less than 2x minus 20. Now I can combine like terms on each side. So I see on the left I can combine a 4 and a negative 3 to be 1. I can also combine a minus 2x and a minus 4x to be minus 6x. Is less than, and on the left, on the right, I do not have any like terms, so it just drops down as is. From here, I want to make sure I have the variable on only one side. Well, right now I have an x on the left side and an x on the right side. So I either need to add 6x to both sides or subtract 2x from both sides. It doesn't matter which I do. If I go ahead and add 6x to both sides, I see that I'm left only with a 1 on the left-hand side. 2x and 6x is 8x. And I drop down my 20, or my minus 20. Now I can get rid of anything that is attached to the variable, so I can get rid of a minus 20 by adding 20 to both sides. And I'm actually going to back up for a moment before I do that. And I notice that this was originally a 4 out front, and somehow I changed. Oh, never mind. I'm not going to back up. It was fine. So I'll add 20. And I'll add 20. And I get 21 is less than 8x. So now I can go ahead and divide by 8. 21 divided by 8, I don't know what that is. I can leave it as an improper fraction. 21 over 8 is less than x. However, when I go to graph it, it's easier for me to find things on the number line if they're written as mixed numbers as opposed to improper fractions. So I'm going to go ahead and do a little scratch work and figure out what 21 over 8 is as a mixed number. 8 goes into 21 twice. And I get, when I subtract, a remainder of 5. So I get 2 and 5/8. So setting up my number line, I have 1, 2, 3, and I'm going to put 4 on there. So if I'm at 2 and 5/8, I'm just a little bit above the halfway point between 2 and 3. I'm going to put an open circle there. And then it says that, remember I read the variable first, it tells me that my x is greater than 21 over 8 or greater than 2 and 5/8. So I'm going to go ahead and shade everything to the right. So again, just reiterating that it is the same steps as we've been using. Just make sure that you're being careful and noticing when you multiply or divide both sides by a negative to make sure to flip that inequality sign. Make sure if you have any questions on that, you're bringing them with you to class.